how much plastic the gut can clear before it crosses that barrier. A 2025 study published in Frontiers in Microbiology screened 784 probiotic strains specifically to find which ones could physically bind plastic particles. Most of them didn't do much, but 2 stood out. These 2 bacteria in particular have a surface chemistry that attracts plastic through a process called hydrophobic binding. The bacteria latch onto the plastic particle and the 2 clump together. And remember that donut hole analogy that I mentioned? That clump becomes large enough, it's not necessarily getting absorbed. Instead, it gets carried out through excretion in the feces. The 2 strains are Paracasei bacillus and Lactobacillus plantarum. So both have GRAS status from the FDA, meaning they are generally recognized as safe, and both are found in fermented foods that people have been eating for thousands of years. Let me go get my kimchi. So before I share the results, I want to be upfront about the limitations of this research because that context matters. This was a mouse and bacteria study. Human trials have not been conducted yet. What we have is a proposed mechanism and animal data that warrants further investigation. And that is a meaningful distinction from confirmed human outcomes. So I'm not saying if you take this, it's going to do that, because that's not what the data indicate. But I'm sharing it because the mechanism is worth understanding and the direction is consistent with what we already know about gut health and barrier function, which is that fermented foods can be incredibly helpful. Not necessarily for everyone, because I understand that some people might react differently, but in general, fermented foods and the bacteria found in fermented foods can help to support gut health. So I want you to remember with that context, here is what the study found. Mice given these probiotic strains showed a 34% increase in microplastic excretion rate compared to controls. And residual microplastics in the GI tract were reduced by up to 67%. Lactobacillus plantarum brought gut inflammation markers, including IL-6, TNF-alpha, and IL-1 beta back down to near baseline levels, even after microplastic exposure. That inflammation finding is worth pausing on because microplastics don't just accumulate passively. Research suggests that they can trigger an immune response in the gut lining that contributes to low-grade inflammation over time, so gut inflammation. And the fact that this specific probiotic strain can help moderate that response while also potentially improving the clearance of microplastics, now this indicates a broader role for gut health in how the body can manage plastic exposure. So these are early findings, they're animal data. More research is needed, but the direction is worth paying attention to.